In this video mechanism, we will cover the next topic related to stack. That is nothing but what is the basic differentiating mechanisms between the stack represented using array and the stack represented using a linked list. So we will see which are the different points on which we can differentiate both of these things. First of all, the stack representation using array is known as static implementation, and the stack representation using the linked list is nothing but the dynamic implementation. Secondly, the stack representation using array, this method does not provide flexibility because as the size of the stack has to be declared, then there will be no change in the size after the program design. For example, using the static means array mechanism, suppose you have created the structure of the stack and you have created the fixed size of that element. For example, as of size 10. Then, what does it perform? It from start to end allocate only 10 memory items. Means it can have the scope of only storing the 10 elements. Means it has the fixed size limitation of the array also applicable to the stack. Means memory can't be extended at a runtime. Okay. So this is the basic limitation of the static implementation or the array implementation of the stack. But this method means stack representation using the linked list is nothing but the flexible mechanism. It is a flexible mechanism. How? Because you are using here the linked list, and you all knows that linked list is the mechanism in which you can extend the memory at a runtime depending on the user demands. So this is the unflexible mechanism. This is a flexible mechanism. Means here the memory limitation occurs and here the memory limitation does not occur. Second, third point is memory wastage is the big problem with the static implementation, because here in this example you are seeing that it is a stack of the fixed size, that is the S of size 10. Means it can store the 10 elements, but there is no need, there is data elements that are having the less capacity, means only 5 elements you have to store in this spaces. So the remaining 5 element space will be wastage. Means these 5 memory spaces will be for other users in a using condition, but actually this data element does not handling this memory element. So these 5 data elements will be wasting the memory which is required by another users. But comparing to the dynamic, memory wastage is not possible. How? Because at a runtime memory will be allocated according to the user requirement. So when user requiring only 5 memory elements, then only that fixed 5 elements will be acquired by the users. No any extra one memory element will be acquired at a time. So here the memory is wasted. Here memory is not wasted. Next, insertion and deletion is requiring more memory, more data movements. Means, for example, here in case of array having the memory locations either in a row wise or in a column wise situation, but having all in a consecutive memory locations. Means all data elements are represented in the consecutive memory locations. So there is a bigger data movements for insertion and deletions also. But comparing it with the dynamic implementation, this linked list representation has a first advantage, that is, insertion and deletion operations do not involve the more data movements. Means not data movement will be performed because only pointer positions or pointer can be changed. So this is the basic advantage of the dynamic implementation over the static implementation. Next comparison will be based on the space required. So the array representation of the stack requires less space, means less space is required because in the dynamic implementation the overhead of pointer maintenance is there. So here more space is required, and here in case of array representation no any extra space required for any pointer storage. So these are the basic differentiating factors between the dynamic implementation and static implementation of a stack. Thank you so much.